Welcome back to the channel, guys. It's been ages since I've done videos and I'm sorry for that, but I've just been ridiculously busy. But moving forward, there's going to be a lot of new videos coming in. There's heaps of builds going on and heaps of crazy custom works that we're doing. So straight up, we're going to hit into Dana diffs. Now, this is something I've been going down the road of a lot at the moment, and basically this first video you're going to get is going to be around retrofitting Dana's two Patrols. So we'll touch base on a couple of components, reasons why you want it, and the benefits that it's going to do for your car. Now let's talk full float. What is full float? It's basically an outer spindle which then houses a hub that goes over with inner and outer race bearings, much the same as what you'll run on the front of a Patrol or Land Cruiser. You have a stub axle, your hub goes over it. Benefits of this is weight bearing capabilities and the actual way you can change the spline of your axles to go input. Now, depending on your bore you have in this, which is different circumferences and everything like that between Danas, you can actually buy straight up different axle inputs and change your locker inside on your spider gears and everything and your input sleeves and that to change your axles purely just off doing that. A common thing with the Dana 6s is they actually bore this out with a hole saw, run it all the way in, buy Yukon new CVs or axles, slam them in, change your locker, you've just upgraded to a 35 spine from a 30. Now, these pretty much, we're all common with this, very common in the Land Cruiser world. They go straight in like this, and then they'll just bolt, ring around like that, press on. Easy to do. We also will be knocking off the old assembly for the brake shield and the hub brakes, and we'll be changing that out for a disc rotor, which is a weld-on kit, and I'll show you how this goes onto assembly. Now, we'll duck down to the Dana 60 and I'll show you what a semi-float is. Now, like mentioned, this is full float and this is semi-float. Now, basically you can see that your stud will be on the inside of this hub drum which goes over, and then this one here is actually on the axle with your hub on here. Now, these in America, they basically say up to a 35. After that, you need to start looking down to full float. These are still usable. People still do run them in the industry on the a lot of custom diffs in the States, but in terms of what you're looking for and what you want to upgrade to, full float is where you're at for weight bearing and the race bearings and everything like that that we're in. Now let's talk about how we're going to prep this diff. Now basically a lot of these F-truck diffs that you'll come across in the rear and even in the front pre-Super Duty is you'll find that a lot of these are always going to run leaf springs. So the perch hangers on here, pretty much just got to chop them off. You got your shock mounts which are pretty easy to get off generally, and then your outer hub assemblies with your shielding and all that kind of stuff. You could still continue to run the drum brake if you choose to, but basically you're going to want to upgrade to a disc brake and get that benefit from the 1-ton disc brake kits you can get for these. That will also help you with your tests when you go engineering for those tyres to go past 7% from VSB 14. Now what we'll do is we'll pretty much go through and completely take this back to bare now, prep it all up, and then run some nice weld-through primer on this and get a real good base on here to start doing all our geometry and brackets. So we'll get into it and start stripping. So as you can see, we've just gone through and completely decked this housing down to a bare housing now. Just going to show you basically the full float hub here and disassembly. Some people might be not familiar with it, so pretty well. They do have a little retainer keyway here that will just pop out like so. And then inside here there's a massive old spindle nut, which I believe is a 2 and a 9/16. So that's got a 3/4 down to a 1/2. Now I'm not going to put this on a breaker bar because it will rotate this housing. So a good old trusty rattle gun on 4. Chuck that on there, lock in, and then that's us. And that will expose this race bearing now. So pretty well, a light little knock on the spindle or on the hub itself. We'll release that and wiggle out those races, simply slide off, and that's us there, nice and easy. Oil's gonna come out, obviously, but it's got a bigger race on the outside, flip it over, inner race, bearing seal, everything like that. That is your hub flange there, which you'll bolt your rim to. So we'll get that out of the way. And then now we're gonna chuck a 19 on. So we'll take that off, chuck a 19 on with an extension, and you'll see this brake shield with these 4 ring bolts around it. We don't need that anymore. Now, with the brake kit we will be using on this, you can actually get bolt-on brake kits, but I'd rather weld it on, and that's the one that we are using as weld on. So, good old 30-year nuts here. See how well they come out. That's one. Because they're going to keep being a pain, I'll leave them half on, like that. That's going to relieve this shield to come off. Now when you take it off, try not to score your spindle, because this here, you get scores on this and everything like that, you'll start ruining your bearings and start elongating them, and they'll eventually chase out and ruin it on you. Now we just got to knock these out. So these are no longer needed now. And that's us there. So pretty well, we'll go through now, wire wheel this down, clean it up, and then both sides of these flanges will get eliminated. We'll cut them off because we're not running a bolt-on 1-ton brake kit. We're actually running a weld-on, and this circumference around here, the OD, is exactly what we want. You could make this a bolt-on one if you wanted, but there's just no need for it. So pretty much you'll assemble your brakes all back on and everything like that. Your spindles, put your brakes on there, get them sitting nice and center and everything and clamped on, and then this here will get welded perpendicular to the housing to suit. So I've just gone through and obviously prepped it down, sandpaper, all that kind of stuff, 40 grit. Got it nice down to the point where most of the pitted holes were all fetched out of the rust and that. But now I've gone through and put a converter on, which is basically going to go through this now, which is 30 years of rust, and start eating right into it. And then we'll let that all do its kind of thing. We'll come back, hit it with a bit of acetone, and then start stripping this down and cleaning it. And that'll give us a really nice base and try and clean this up. Now the rust converter is probably one of the best things to use on these Danas in terms of chemically treating them and changing them and converting them back so that you can actually pull all this embedded stuff out of the housing. And yeah, it's really a cost-effective thing. Now, we've let the rust converter do its job, so hit it with a bit of acetone. I like to use these pump bottles, I just fill them up. The dearer ones you buy can handle the different products you put in them, so don't cheap out and buy shitty ones. Get a decent brand. Spray this on now, a bit of acetone. Give it a real nice clean up, and it will start pulling off all that shit. Now, I probably do recommend wearing some gloves for this. Depends if you're hard or not, but give it a nice little rub around. And you can see like that, it's starting to come up real nice. Now, you're not going to get it back to factory, that's a given, unless you want to spend 5 weeks on this, which I haven't got the time for that. But you'll get it to a point where it's somewhat reasonable. It's only going to get painted anyway, but you want to remove the underlining debris and rust so that it doesn't actually flake your paint and start pulling through. Obviously, a lot of paints these days, if you get the right one, have rust inhibitors in them, and they'll actually stop that from rusting further and flaking it all up. Now, generally, something like this, I'd probably prefer to run like a Steelit on it, which is a good American paint, and that has a lot of properties in it, rust inhibiting, stainless steel, got a polyurethane coating in it, which is quite absorbent to kinetic energy and bouncing and that off stuff and rocks. So that will help stop it from chipping, because it can actually absorb and repel energy instead of being like powder coat, which is quite hard and doesn't like being chipped. Anyway, that's us. We're going to knock these flanges off either side, and start fitting up some brakes and brackets. So the next step we've got now is to basically prep these housings. So as you would have seen, I was talking about these flanges that were on the end of this, which houses your drum brake assembly. Basically you don't need that anymore. We're chopping it off because that weld-on kit we've got for the brakes, which come with these brackets, that OD there goes bang on like that. Do a nice couple of welds through that, and that's all you need. So that flange doesn't need to be there. There is kits that do have the bolt-on ones, but this one doesn't. So basically that gets eliminated. Now gone through, chopped them off, cleaned them all up, polished them out, got them pretty even all the way around, just so that we can align this brake calipers up and the pad's nice. And now pretty well, all we got to do is slam these hubs back on, set that spindle nut back on, compress it all in, get it all nice, and then we can work out that position of the brake. So the preparation there is a key element, because how you put the assembly back together will dictate where that brake does sit. Now, because you are welding it on, it's a bit of a one-hit wonder. So you can see down here, I've got these hubs all assembled, and I'll zoom in on it and show you sort of what we've done. So with this assembly here on the hub, it's not a very complex setup on what you got to do, but pretty well you are putting the disc brake to the back of the hub, and this disc brake here is a K20 Chev, so 1985's kind of era. It's a front disc brake, and that's what they use on the rear with the larger piston and everything like that. Inside of this, you'll see it's all been nice and cleaned up. I wire wheeled this down and got it all looking pretty nice. All these new studs are about 10 to 15 mil longer. They've got a bit of a step out gooseneck in them, which helps bed and locate this rotor to the spline that goes through to your hub. So there's a bit going on. Now what you got to be super careful of is that these studs that are on here, that hole diameter, it's somewhat of a interference fit, and what I mean by that is basically you're pressing it in to a degree. Now you got to remember that the internal hub has a spline key in it already, so you don't want to be pressing too much. But pretty well, when I chucked it on the press, I took it to about 5 ton each one, pressed it nice and completely sealed them all in and rotated that around. And when I was doing that, a simple thing I've done, pretty much sit it on the bench like this flat, measured from that hub to the surface here, and then I think it was about, I don't know, 76 mil, something like that. I cut up some tube, and then you fish that over the stud and press down on the tops of that with that, so it's bedding it through, and you've got a nice surface area here to push against, so that you're not, you know, got the potential to spit something out on the press. Now, when I went to go do this, I did some tolerance fits and stuff like that and checked it. It runs like a 11/16, which is something like a 17.34 mil. So I took it to a 17.5 mil drill bit. Like the pricing of imperial drill bits to metric drill bits, with what we're doing on this, we don't need to be super tolerant in what we were doing, because we do have the keys below as it presses through the housing. That's something you don't want to touch. But yeah, 7.5 mil drill bit, sent it through nice and slow, chipped it away. Cobalt is the key here. You don't want to be using shitty high speed drill bits and stuff like that. They will wear it real quick. So nice cobalt drill bit, chuck that in the drill press, sent it through. And then now we've got this all assembled, polished up. So we'll chuck that on the spindle now, a little bit of bearing grease, put the other race bearing in the front. Now these bearings are clapped out old, but for now it's just test fitment. Basically all we're doing is assembling this diff, and then the customer will rebuild it, locker, gear set, all that kind of stuff later on. So I'll just send it on there, a bit of nice hub grease on there to lube it up for now, and then we'll start setting up this brake bracket. Right, so we'll chuck this hub assembly back on now, but a quick little pointer here. These machine threads on the end of these spindles, just be careful, make sure you debris out of them and stuff and they're nice and clean, because these spindles have to be chopped off and welded if you want to replace them. They're not like ones that are bolted on to a flange. So pretty well now, we'll open up a bit of hub grease. And like I said, for now, this is just to help spin it on, get it all nice before the customer fully rebuilds it and fits it out. That's just on there like that. Chuck a little bit on the nut here. Easy, and then make sure you don't get hub grease on your disc brake, because you'll contaminate your brake pads and fuck them up before you even get them in. Now, pick this hub up. Slide on. They do have a back seal on these. Where are you? There we go. That's that there. And now, that race that we've got, obviously, like I said, it's an old one, but for now, this will set us up by preloading that spindle nut. Chuck it in quickly, just get a little bit of grease around that. Slam that in the front here, and lifting up our hub, like that. Push it in with your fingers. Then now that hub socket nut that we've got will actually sort of act as a bit of a press to push this race down a little bit, like so. And then our nut, start it off real nice and slow and just find its starting point. Don't try and cross thread it, and then get about 3 to 4 threads in. That's all good. Chuck our spindle hub socket on there, wind it in by hand, and I'll start seating the back side of this now. And now we'll get the rattle gun. Obviously you can just have a 1/2 inch ratchet too. Just gonna chuck it on one. Do a little bit of play on that. Like I said, it's only on one, so it's barely doing anything. And that's pretty good there. A little bit more. Alright, awesome. So, now that we've got that on, we can slam this brake caliper bracket over. Where is she? Right here. So, we'll bolt our caliper to this, and then we'll slide it over with the pads in, and we'll be able to work out where we want to tack this in place. Now, this will be sufficient in terms of just welding both sides, but I think I will chuck a little gusset on the inside here, just for peace of mind. I think that will just help a little bit. So yeah, we'll chuck that brake on and then set up the welder, and we'll start welding it out. We've got the tricky part now of actually assembling this brake caliper and trying to situate it where we want it on the diff. Now, the orientation or anything like that, we'll have to rotate it. Inclinometer off the diff will sit true 90 degrees perpendicular to the table, which I've already set up now. We'll chuck that on top of this bracket. We'll run that at 30 degrees, which is reference to this being 90. Once this bracket is on here and rotated, and then we'll push the caliper side, which has the piston, as hard as we can to the disc brake, because when it actuates, we'll actually pull the other side as a slide and run across. So there's a couple of variables you got to do. The multi-grips up here, or vice grips that are on here, they're purely there to hold the tension on the bracket to keep it actually compressed so that your bracket's not at a bit of an angle. I don't know how significant it would be, but I would assume it would start to run a pad on an angle a little bit, and it would start wearing it down on angles. We're not trying to do that in any way, shape or form. So pretty well what I'll do, I've got the MIG set up here. Now don't hate on me because I do tackle all the time with no helmet on, and it's purely just so I can see. But it's not a good practice, and I know that. But anyway, we'll get into it and I'll chuck this on. So we're pretty well gonna now get an inclinometer. We'll chuck it on the desk. That's all zeroed. Now we're chucking on the housing. Housing's 90 degrees, which is awesome. And now here's the tricky part. So you have to have the bleed screw to the top. That's what you need for when you bleed these systems, the air out of it and everything like that. And yeah, pretty well the 30 degree on this bracket cut here. That will sort of give you the same kind of setup or orientation as a Patrol pretty well. So pretty generic on what we're doing here, nothing too crazy. And the preparation that we've done on here is key, because you can see it's pretty much to the millimeter of sitting that on there really nice. If you did that shit and you scalloped it out or it wasn't nice, it wouldn't sit great, so you'd be fighting even more factors, because we've got rotation, angle, we've got compression of this being seated and true to the brake pads,
and then you'd add that variable in there of it being wobbly. So at least we're minimizing the amount of things we've got to do. So chuck that on here, and these things are super cost effective and everyone should have one in their shed. They're literally $30 and the amount of things that they do is ridiculous. So that's about 31, 30, ooh, about there. And that's exactly where we want this. Now, compress that as hard as we can so it's running this nice. Oh, that table's gonna move, shit. I'm not gonna lie, this is a bit of a... Just because I like everything to be really well done, opposed to just tacking it and hoping it's all good. Where are we? Right about there. Ooh. Alright, so it's about 31 degrees. We just have to mimic that on the other side. Obviously we'll move around a little bit and shit. But as long as we're seated is the biggest thing that we want here. So obviously the tact at the top there, as long as we get even gaps and everything, and that's all good. Now this caliper does have a cutoff on the rear, and I don't know how well it's going to be in terms of level or perpendicular. But go back on the bench, that's 0. We'll chuck that on here, and it's 0.6 of a degree. Now that's not too bad for a tack. So all we're gonna really have to do is find where that's right there. So all that was a little bit of thumb pressure down the bottom here, and that's now housed it so that caliper is perpendicular to this housing and bang on. So pretty much go through now. I'll chuck some more tacks on, and then we'll go through and weld these completely out, and then chuck some internal gussets here just to sort of take that flex out of it. It's not really a crucial thing that we need, but just for looks and you know, aesthetically pleasing, it's just sort of going to be a bit more of a brace there, help with that, because they are a big kit, big brakes, a lot of movement going on here and stuff like that. So I'll just chuck a little bit more in there and tie it up a little bit. Up there. Basically part one's covered through prepping the housing, a bit of information about the Danas, and we've also assembled the brake kit on it. So we'll leave this episode there and we'll jump into part 2 next week. So part 2 is going to jump into truss kit, link mounts, panhard brackets, alignment, everything you need to take in consideration. As you can see behind me, I've got some brackets in CAD already drafted up, and this is leading into what I've been doing lately in terms of production kits for these. So somewhat of a 60, 70, 80 Dana and a 14 bolt Chev. And that's pretty well designing all these files together and embedding them in so that they can work on different diffs for you guys. So in the next week's episode, you'll see one of those kits that I've produced and welding it out, how it's going to look on the diff and what it can sort of achieve for you. So anyway, we'll wrap it up there, and I hope to see you in part 2.